All right, welcome to the beginning of our new unit. Our new unit is on the conic sections, or the sections, the shapes you get when you slice a cone or a double napped cone. And we'll dive into the conic sections tomorrow, but today I want to look at the most basic of all conic sections, the circle. And we're doing that because I just want to connect it to something you've already studied. You've already studied circles in geometry rather extensively. You also studied the algebraic interpretation of the circle, meaning what happens when you put a circle on a coordinate plane. So a lot of what you see today is just review. We just want to make sure your skills are where they need to be. So let's just go back and talk about geometrically, how do we define a circle? So geometrically, we define a circle as the set of all points in a plane meaning it's flat, that are equidistant, or the same distance, from a given point. Now we call that distance the radius, and we call the given point from which all the other points are equidistant the center. So now we want to take a look what happens when you put that circle on the coordinate plane. So algebraically, we can derive the equation of a circle. Whoops, don't look at that. We can get the equation of a circle where we define the center as the point h comma k and the radius as this variable r, this value r. And that algebraic equation is this. R squared equals the quantity of x minus h squared plus the quantity of y minus k squared. And again, this is a formula you've seen before. And let's just talk a little bit about what's going on here, and then we'll see where this formula comes from. So real quick, we have our point hk, and this is a given point, and this is going to act as our circle. And from that point, we can go out a set distance called the radius. And that set distance, the radius, takes us to another point, x comma y. Now the question we were going to ask ourselves, is this the only direction that we could go out that radius length? And the answer is no. We could obviously go out in all these different directions. And all of these points, x, y, form a circle. So there's my center, and from that center we reach some point by going out a set distance. And not just some point, we reach an infinite amount of points. And I always love to ask my geometry kids, what color is this circle you see in this picture? And they tend to say it's gray. But actually the circle is black. Remember, the circle is the set of all these points that are equidistant from the given center. So let's go through some basic exercises using the formula, then we'll see where the formula comes from. Exercises. All right, let's take a look here. Maybe we'll just cover this up. Oh, I can't get to that. All right. So first, write the equation of a circle where I give you the center and I give you the radius. So I suppose what we need is this equation written down here in our notes. And let's just plug and chug. So I have the center. That's what I need, h and k. I have the radius. It's 6. And so I guess the answer would be 6 squared, 36, equals x minus negative 2, x plus 2, quantity squared, plus y minus 5, quantity squared. Simple. Simple. The equation of a circle. Let's do another exercise. Number 2, write the equation of a circle with a center at 0, negative 12, and the diameter is 16. So pause the video, write down what you think it would be, and come back and check. Hey, welcome back. Did you pause it? And did you write this down? X minus 0, or just x squared, plus y minus negative 12, quantity squared, equals the radius squared. And if the diameter is 16, we know the radius would be 8. So 8 squared is 64. Let's do one more exercise. Ooh, this one you definitely have to pause. Look at it. Look at it. Yes, yes. All right, welcome back. I hope you paused it. So I guess the first thing we had to do is find the center by solving this system of equations. I found that center to be 2, negative 1. And then I had to find the radius, but I gave you the circumference. Remember, circumference is 2 times pi times the radius. And so it's just a matter of plugging and going through the math, and I got the radius to be 5. So there's my center, there's my radius, and I plug them into the equation of a circle, and that's what I got. So fantastic. Those are basic exercises kind of built just to make sure you're familiar with the equation. You can use the equation, but now I think what's on everybody's mind is why. Look at that video. See how they rotated in a circle? That was a pretty cool graphic there. Oh, there they go again. Yep, that's a good one. All right, well, let's talk about why. So I have here a circle, a black circle. Remember, the circle is the set of all points, all these points. And the center is HK. I go out some random distance called R, and I arrive at this point XY. And what I want to do is I want to see if we can find the equation of this circle. So let's see here. Well, you know what I could do is I could come straight out from this point and come straight down from this point. And if I do that, I get this right triangle here. Now, the million-dollar question would be, what are the coordinates of this green point? So why don't you take a second, sketch this circle, pause the video, and see if you can figure out the coordinates of that green point right there. All right, did you get it? Well, I would say that the x value of this green point would be x, because it's directly below that point. And the y value of this green point right here, the y value should be k, because it is the same height as this black point. And now I have a right triangle, and if I have a right triangle, I could use the most famous of all theorems, the Pythagorean Theorem. Let's think about this for a second. How long is this segment right here, this horizontal segment? How long is it? And how long is this vertical segment? Well, maybe I could get you to pause the video again and see if you could figure out the length of that green segment. Okay, here's what I got. X minus h, right? This horizontal piece minus this smaller horizontal piece, and then this vertical, y minus k. Yes, indeed. So now that we have all three sides of this right triangle, we can employ the most famous of all theorems, the Pythagorean Theorem. In a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. And if I wrote that out, that's what I'd have. And that, ladies and gentlemen, is the equation of a circle. Funny to think that a circle, or its algebraic interpretation, comes from a right triangle. But that's how we come up with this generic formula for a circle. Pretty outstanding. Well, we did some exercises. Those were nice. Let's get into some problems. First, well, all right, this is an exercise. First exercise. Is the point 6, 0, is that inside, outside, or on a circle defined by this equation? So one thing you might do is you might go and grab some graph paper, and then maybe you go over and you plot this point 6, 0, 1, 2, 3, 4, 5, 6, 0 right there, and maybe you plot the center, and the center looks to be 4, 2, 1, 2, 3, 4, 1, 2, and then you say, okay, if I draw this circle coming from this center here, and the radius is 3, and the radius is 3, so it goes out to, that point, and it goes to that point, and it goes to that point. And let's see, the radius is 3, and it goes down to that point right there. And maybe if I sketch that's not the point. And maybe if I draw the perfect circle, you've seen me draw those perfect circles in class. Then we could see if this is in, on, or outside. And so oh, that's not a good circle. Well, that's not really going to help. So maybe what we could do instead is think about this a little bit. We know that the equation of this circle looks like this, where we have an x and we have a y. And I would say that if a point is actually on the circle, then it should make this equation true. Meaning, I could put a 6 in for x, and I could put a 0 in for y. And if I did that, I would get 9. It would work out to be true. That's what it means for a point to be on a graph. It satisfies the equation. So let's put a 6 in for x and a 0 in for y. And let's do the math. So the left-hand side gives me 2 squared plus negative 2 squared, and I want to know how that relates to 9. Well, 2 squared is 4, and negative 2 squared is 4, so 8 is less than 9. So it's not on the circle. So what I've figured out is the distance from this point to the center is the square root of 8. So I'm going to say, since 8 is smaller than 9, this point is inside the circle. That was a good one. That was a good one. Let's try another problem. Write the equation of a circle that has a diameter with endpoints at 6, negative 5, and 0, negative 3. Well, I suppose the first thing we're going to have to do in this problem is find the center of the circle. So, use your algebra skills and find that center, which I found to be 3, negative 1. Now we have the center of the circle, so I can do half the equation. Quantity of x minus 3 squared plus quantity of y plus 1 squared equals what? So in order to find the radius, what I did is I constructed this little right triangle right here. I came straight down and straight over, and I found this length. And of course, if this value is 3 and this x value is 0, that length would be 3. And I found this height, and if this y value is 3 and this y value is negative 1, that's 4. And using the Pythagorean Theorem here, this is 3 squared plus 4 squared. This value right here would be 5. Right there, I made that a little bit too big. So that's the radius, 5. And of course, this is the radius squared, or 25. Well, now let's go on to the last two problems. And the last two problems are finding the coordinates and of the center and the length of the radius of the following circles. So I have here the equation of a circle, but look, it's all jumbled, which means I want that circle to be written in factored form, and it's not. And this is going to involve the algebraic process of completing the square. I know last year in algebra you hated completing the square, but this gives us a reason for why we need to do it. Now, if you're not good at completing the square, sounds to me like you want to watch my follow-up video here on how to complete the square. But if you know how to complete the square, go ahead and pause this, try A, and then come back and see if you got it right. Hey, welcome back. Hopefully you tried it, and if you did, you found that this is the equation you get when all is said and done, when you grouped your x's together and completed the square for x's, when you grouped your y's together, completed the squares for y, moved this 17 to the other side by subtracting it, and then put in your extra additions here to the other side. So this means the center is negative 1. Negative 5. Oh, Mr. Barath, shame on you. Negative 5. And the, all right, that's a negative. And the radius here is 3. And again, if you weren't able to complete the square, sounds to me like you got some video watching to do. Part B, oh my goodness, we got to complete the square again, and we have fractions. So pause the video and give it a go. Oh, look at that. And then the center and the radius. So hopefully this makes sense to you. I have some problems on an accompanying worksheet I'd like you to go through and try. And again, if you need to watch a video on how to complete the square, watch it. All right, take care.